First thing we need to do is we're going to take the nice, pretty form that we looked at yesterday, and just let's recall that quick. Yesterday we had this HK, and just by looking at the HK, we knew how it moved left and right, how it moved up and down. And then also from that, we knew vertical asymptote, horizontal asymptote. And then also from that, we knew what the domain could not be and what the range could not be, right? Just by knowing how the graph moved left and right, up and down, we knew where everything was or what my asymptotes were. Today, we don't have this nice, pretty form. We have something like this, what's called standard form, where you're going to have a polynomial over a polynomial like that. Okay, so let's recall, we're going to have to be factoring today. So let's recall a couple ways of factor. If I have a quadratic that looks like this, how would I factor that? What do I multiply equals 2 but add equals 3? So this would factor into x plus 2, x plus 1, right? If I set this equal to 0, what does x equal? -2 and -1, because that would make each of these 0, and I'm multiplying, and we know when we multiply by 0, it equals 0. Good. The other way we're going to factor would be something like this. How do I factor that? What can I factor out of both terms? A 3 and an x. What's left in the first term? X. What's left in the second term? 3. And if I want this to equal 0, what's x? -3 and 0. Yep, because this is where I'm multiplying, so either x is 0 or x is -3. That means each part of the product 0. Okay, good.
Now, what's the word that's going to give us a headache?
The other thing we need to remember about a fraction, right? If I have a fraction, let's do okay. When I have a fraction, what do I know about the denominator? If I'm dividing, what value can I not have in the denominator? 0. You can never divide by 0, right? That's impossible. It'll say error on your calculator. So when I'm looking at domain, what x values I can have, we need to look at the bottom and say, okay, what x values would make this bottom 0? Because x values that make the bottom 0, I can't have those in my domain because you can't have 0 in the bottom fraction. So we factor, right? And what values would make the bottom 0? Can you see that? Factors into x plus 3 and x plus 1. So my domain cannot be -3 and -1 because that makes the bottom 0. Okay, if x cannot be -3 and -1, that must mean I have asymptotes there. There's some sort of discontinuity there if x cannot be that. Okay, so there's two forms of discontinuity. There's a form where I can have a hole in my graph, or the part where I have a vertical asymptote in my graph. Okay, holes are this. Holes are if I have something the same on top and bottom that I can cross off. It goes away in y equals x plus 3, but you can't forget that it was there. There's actually a hole there. So when I graph this line x plus 3, it's a line, but there's a hole there because originally I had the x plus 2. And I know I can't have 0 in the bottom of a fraction, so my domains x cannot be -2, and then I have a hole there. Okay? If it doesn't cross off, I have a vertical asymptote. Okay? So if I factor the top here, see how these x plus 1s would cross off? That means this negative 1 was a whole. Okay? X plus 3 didn't cross off, but still x cannot be negative 3. That means that's a vertical asymptote. Whatever x cannot be is defined as a whole or vertical asymptote. Okay, you with me so far? Okay. The other thing you can see is a continuous function, and that means there is no x value that I can sub in to make the bottom 0. I can't square a number, add 1, and get 0. That's impossible. And if you don't see that, the red flag that'll tell you that is if you start to solve for what's going to make that equal 0, you'll end up square rooting a negative number, and that's imaginary. You can't have imaginary asymptotes. Okay, so whenever you start squaring a negative, stop, because you don't want to go there, and you would just say, oh, none. There isn't one. There's no way I can make that denominator 0. Okay? And when you're factoring, a lot of students see, oh, they both have x squareds, let's cross those off. You cannot do that. You cannot cross off part of a polynomial. This is x squared plus 1. You cannot just chop off part of that polynomial. Okay? The only time you can cross stuff off is if you have the same polynomial, like x plus 1 with x plus 1, x plus 2 with x plus 2. You cannot cross those x's off. You can't do that, because that would be chopping part of it off. Okay, good. Okay. One more thing I want to go over before we do an example is x-intercepts and y-intercepts. X-intercept is when it crosses the x-axis. What do I know about all points that cross the x-axis? Y is 0. Okay? Now, when I have a function like this, and I want y to be 0, that means I want this fraction to equal 0. How does a fraction equal 0? If the top is 0. If the top is 0, 0 divided by anything is 0.
Or if there's nothing there at all.
Okay, yep. So when I'm looking for x-intercepts, I'm setting the answer equal to 0. What I'm doing is I want the top equal to 0. What x value would make this top 0? In this case, it'd be negative 4. Negative 4 plus 4 is 0. 0 divided by negative 6, right? If I put in a negative 4 for x here too, would be 0. So my x-intercept on this one would be negative 4. Y-intercepts are when x is 0. So that's just kind of an algebra 1 problem. Put 0 in for x and solve it. 0 plus 4 is 4. 0 minus 2 is negative 2. 4 divided by negative 2 then is negative 2. So my x-intercept in this case would be negative 2. Okay? So you're just going to sub 0 in for x and solve is what you're going to do. Okay? So we're going to take all that information for each function. Okay? So out of those things, then we have continuous functions, which we can't get the bottom equal to 0. Or we have discontinuous functions where we can make the bottom 0. So whenever you have a domain that can't be something, it's discontinuous. Otherwise, your domain's all real numbers. If you have discontinuous functions, you either have what we call a removable. This is removable when you have a hole. A hole is a removable discontinuity. And an asymptote is a non-removable. And that says that all down here, if you look down here. So if you put this in your notes, when you see you have a vertical asymptote that's discontinuous non-removable, if you have a hole, it's discontinuous removable. If domain is all real numbers, then your graph is continuous. The first step you always want to do is factor. Okay, so look at the top. Can I factor the top? Is there anything I can factor out or no, right? What about the bottom? Can I factor the bottom? I can take an x out. Very good. So this bottom factors into x minus 2. Okay? So that's always your first step. You want to factor the top and bottom. Okay? Once you have everything factored, then you can start looking at the domain. And when you're considering the domain, you want to look at the bottom. And you look at the denominator and think, okay, is there any x values that would make the bottom 0? Because x cannot be those values. So if I look at the bottom here, x cannot be what? 2 and 0. Yep, 2 and 0, because that makes the denominator 0, and you cannot have that. Okay, if I have x can't be something, then I'm thinking, okay, this is discontinuous. So I have vertical asymptotes, I have holes, or I have both. Okay, so let's look. Vertical asymptote and or holes. So for a hole to occur, something has to cross off on top and bottom. Can I cross something off top and bottom? Is there any matching terms or polynomials? No. Okay, so in this case, there are no holes, right? Holes are none. That must mean both of these are vertical asymptotes. So vertical asymptotes, I would have 0 and 2. And that was similar to yesterday. Yesterday we did asymptotes, then defined domain. Today we're doing domain, then to asymptotes. They're still related. Okay. All right, then after looking at that, we can now look at what are my x and y intercepts. Okay. So let's look x-intercept, y-intercept. Okay. X-intercept, if you remember or look in your notes, is when y is 0. So if I want this to be 0, how do I get a fraction to equal 0? What makes a fraction equal 0? If the top is 0. If the top is 0, 0 divided by anything is 0. So now I look at the top. Is there an x value that I can sub in and add 5 to equal 0? Right? And the answer is no, because you can't square something to get a negative. That's impossible. So there's no way to make this a -5. To add 5, get 0. If you didn't see that, you would write it out, set it equal to 0, start using some algebra 1, and you'll end up square rooting a negative. And like I said, whenever you start square rooting a negative number, stop. Don't do that. That just means there isn't one. So since there's no x value I can sub in there, a real x value, we would say none. There isn't an x-intercept. There's no x value that makes the top 0. Y-intercept. Y-intercept is now when I put 0 in for x, all of my x's, right, and solve. Now, I should recognize here that x can't be 0, right? We should hopefully recognize that. So y-intercept is actually none because x can't be 0. But let's say we didn't notice that and started putting 0 in for x. You should still notice that you're going to be dividing by 0, and you can't do that. So still none. Okay. All right, now, is this continuous or discontinuous? If x cannot be something, right, that's discontinuous. If I have a vertical asymptote or a hole or both, that's discontinuous. Okay. Is this discontinuous function removable or non-removable? I don't have a hole. I only have vertical asymptotes. So that's non-removable. Example, first step again, I want to factor. What can I factor? Can I factor the top? What can I factor out of both terms? An x, yep. Can I factor the bottom? No. Yep, there's nothing I can factor out. I can't, nope, nothing. Okay, so that's done. Okay, so step 2, domain. So I look at the bottom, right? Because I can have any x value except for an x value that makes the bottom 0. Is there any x value that would make this bottom 0? Can I square a number, add 2, and get 0? No, impossible. You can't square something to get a negative 2. And if you didn't recognize that, I would subtract 2, and then I would realize, oh wait, I'm going to be square rooting a negative number. Doesn't exist. Okay. So domain is actually going to be all real numbers. I can put any number that I want in for x. Nothing's off the table. Any number that you tell me I can put in for x, I'm okay. So then, if domain is all real numbers, what do I know about vertical asymptotes and holes? There's none. If there's no points of discontinuity, if x can be anything, then I don't have vertical asymptotes and holes because there's nothing that breaks up my graph. Okay. But I can do x and y intercepts. Okay. So x-intercept, I want 0 for an answer here. How do I get a fraction to equal 0? You set the top equal to 0. What x values make the top 0? 0 and negative 2. 0 and negative 2 are my x-intercepts because that makes the top 0. 0 divided by anything is 0. What about the y-intercept? Y-intercept, what do? I put 0 in for x and solve it. What do I get? 0 times 2 is 0, and 0 divided by 2 would be 0. Right? If you put 0 in for x and simplify and solve, that ends up equaling 0. Would this be continuous or discontinuous? Continuous, because domain's all real numbers. That means there's no break in my graph. So this is a continuous function. Okay, so first step is to do what again? Factor. Very good. We're going to factor. So how do I factor the top? What can I factor out of both terms? 3. I can factor the bottom. You guys recognize this as the difference of squares? Or you can put a 0x in there if you didn't recognize that it was difference of squares and say, what do I multiply equals negative 1 but add equals 0? 1 and negative 1. So this bottom actually factors into x plus 1, x minus 1. Okay. Now, let's look at the domain. So domain is x value. So I look at the bottom. Is there anything x cannot be? What would make the bottom 0? Negative 1 and positive 1. Very good, because negative 1 plus 1 would give me 0, and positive 1 minus 1 gives me 0. So in domain, I know we cannot have negative 1 and 1. If I have something that x cannot be, I must have some sort of vertical asymptote or hole. Or maybe both. Is there something that crosses off on the top and bottom? This crosses off. That's a hole. Okay? So my positive 1, because 1 minus 1 gave me 0, my positive 1 is a hole. Therefore, if the 1 is a hole, the negative 1 then would be my vertical asymptote. Okay. All right. Now, once I have the holes crossed off, okay, and I have them accounted for here and in my domain, now my function is 3 over x plus 1. So when I do my x and y intercepts, I'm just looking at 3 divided by x plus 1. So x-intercept, y-intercept. Again, x-intercept is when y is 0. So is there a way I can make this fraction equal 0? meaning can the top equal 0? That's gone. So can I make 3 equal 0? No. So that's none. Because the x minus 1 is gone, and you can't make 3 into 0. How about y-intercept? Y-intercept, I put 0 in for x and solve. So 3 divided by 0 plus 1. 0 plus 1 is 1, so what's 3 divided by 1? 3, right? Because you're going to put 0 in for the x here and solve. 3 divided by 0 plus 1, 3. Would this be continuous or discontinuous? Discontinuous because whenever you have holes in vertical asymptotes, that's discontinuous. And this one would actually be removable and non-removable because we have both. So last example here. Again, my first step is to do what? Factor. What can I do to the top to factor? Take out a 3. What can I do to the bottom to factor? What do I multiply equals 6 but add equals negative 5? Negative 3 and negative 2. Good. So then step 2 is you got to consider your domain. Is there anything x cannot be? What x values make the bottom 0? Because x cannot be those values. So x cannot be 3 and 2. Very good. Because that makes the bottom 0s. Now, since the domain x cannot be something, I'm going to have some vertical asymptote and or holes. Let's look for holes first. Does anything cross off? Yes. What crosses off? The x minus 2. Right now, these are exact opposite. This is a positive 2, that's a negative 2. That's a negative x, that's a positive x. So to make those the same, what we can do is factor out a negative. That becomes, this is negative, and then this becomes positive. Now they match, and I can cross them off. So whenever you have binomials that are exact opposite, you can make them the same to cross off. So I have a hole where? At 2, because 2 minus 2 is 0. Therefore, if the 2 is a hole, then this 3 must be the vertical asymptote. Now, for the x and y intercepts, this x minus 2 thing is gone. We crossed those off, okay? So when you're doing x and y intercepts, you're just looking at negative 3 over x minus 3. That's what you have left. Okay, so x-intercept is when y is 0. Can I make this fraction equal 0? No, there is no way I can make the top equal to 0, so there is no x-intercept. Okay, for a fraction equal 0, the top has to be 0, and that's impossible. So none. What about y-intercept? Can I put 0 in for x and solve? Yeah, so what happens when I put 0 in for x here? I get negative 3 divided by negative 3, which is 1. So my y-intercept's 1. Would this be continuous or discontinuous? Discontinuous because I have holes in vertical asymptotes. And I have a removable and a non-removable.